up is 510 is like setting up the problems. 510 is basically these steps. 510 is these steps. 511 is these steps. So we're working on like the same type of problem for 2 days. We're just like today we're really just setting it up and stopping. And then tomorrow we go through and solve it. Some of the setups I think are way harder than the solving. So I think the idea behind that is like let's just make sure we get those straight and then go from there. But either way, the idea is we're trying to optimize something. Trying to maximize. I mean, these are like real life things actually that you can use calculus for. So I've got a certain amount of fence. I want to fence in the most amount of yard I can. There's a river over here and a barn over here. Like, what dimension would I use to maximize the area? Packaging like something you're going to sell. You want to minimize the surface area, so you spend like the least amount of money that you can, but have a large value. And oddly enough, the shape that does that the best is a sphere. But you can't like stack spheres on grocery shelves, so no one makes things in spheres. Minimum, if you're going into econ, like find the minimum amount of money you can spend to do this, or the maximum amount of profit. I'm trying to find the optimal setting for something, maximum or minimum that makes things work. Some of them are more realistic, like real life things. Some of them are just more kind of straightforward, like two numbers. So my guess is you guys could look at that number one and kind of like try some things in your head and probably end up with it. But let's look at how to do it calculus wise. Draw a picture if applicable. There's no real picture for that. Two numbers whose sum is 30, its product is as large as possible. This is what we're trying. Large as possible means we're trying to optimize that. We're trying to maximize the product. So the equation that I would come up with there is xy equals max. Actually, you could call it like yz equals max and bt equals max, whatever. It's just two variables represent two numbers, and I want the product of them, which means multiply, to be as large as possible. The next step that we're going to get to tomorrow is you want to take the derivative of this. When we're taking the derivative of it, we only want one variable. Sometimes they set up right away with only one variable, and sometimes you have to do another equation and use that to substitute. So in this one, my other equation is the sum of the two numbers is 30. So what equation is that? X plus y equals 30. And then my goal is to take the equation that was equal to max or min. This is the important equation. And rewrite that equation so it's only in one variable. This is the secondary equation we're using to do that, but this is like the main one we want. So I could solve that for either variable. So let's say x equals 30 minus y. Well, that would mean then 30 minus y times y equals max. So I just substituted instead of x, I'm putting the 30 minus y. And then we're going to go from there tomorrow. But today it's just, that's the goal. We're just trying to get to there. Draw a picture if you can. You can't in this one. Write an equation that's going to be optimized. Did it. That has two variables, so what else can we use to substitute so we only end up with one variable? Questions on one I can answer? These can get pretty difficult because I can't go through like every type of way they're going to be set up. So you gotta kind of battle sometimes to figure out like what the equation is that's going to relate things. Some people love that, some people don't. Second one. One point on the graph, y equals the square root of x. This is y equals the square root of x. It's closest to the point 50. So the closest distance is perpendicular, I think, right? So it's probably like somewhere around there. What on earth just happened?
Wow, you're such an artist.
Oh, magic. You do that really fast.
I don't even know what happened. I don't. I would love to. Okay. So this is. I'm afraid to write that. That's the point 50. Somewhere up there is the point that. Like we want the point on this graph that's closest to that point. So we're getting closer, 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 closer. So I'm a huge nerd in two ways for this story. So one, I'm going to talk about Fortnite. You know how you're like driving in the plane and you set like where you want to land? I always try to jump off perpendicularly, so it's the closest. That's kind of the same thing. Like the battle bus is going, you're trying to go here. You want to jump out as close as you can. So that's gonna be, you're getting closer, but then at some point you start to get further. Anyway, that is gonna have coordinates to it also, which I'll get to in a second. Closest to. So what am I trying to maximize or minimize if I want the closest? I want the minimum distance. You guys like combine and you get the right answer. So the minimum distance. Do we remember the distance formula? That's slope. Those things are involved. Anybody? Say it again. No, never mind. It's just Pythagorean theorem. So, should I explain it or just tell you? Did we explain the formula or just tell you the formula? Explain it. Okay. So if I have like, this is like x1 comma y1. This is x2 comma y2. This would be the distance between them, right? The diagonal. What is that distance right there? Isn't it y2 minus y1? Like the distance in between those y values? What is this distance right here? It's going to be x2 minus x1. So then I would use Pythagorean theorem, and I would say y2 minus y1 squared plus x2 minus x1 squared equals, let's say I call that like c, equals c squared. With me? That's not what I'm stepping in. So then what is c? Would be the square root of all that stuff, right? And that's the distance for it. So if you remember it, great. If you get stuck and this made any sense, you can kind of like figure it out from there. Yeah, if I've ever seen it on the AP test, they've given you the distance formula, so I wouldn't worry too much about like memorizing it because they want to test your calculus, not your memory. Is everybody still writing that? Okay. So the distance formula says square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the distance between the x values, distance between the y values. Square and add them up in square root. So it's just two sides of a right triangle. You're squaring them, adding them up, and then square root. But that's got two variables in it. And I didn't even use my 5 and 0 yet. Well, 5, 0 is fine. Like, that's not going to cause a problem with two variables because those are just numbers. The point that is closest, so like whatever it is around there, I can call that x comma y. It is x comma y. The problem with calling it x comma y is that I just use two variables. What could I put in place of the y that would make it so I'm only using one variable? Square root of x. Isn't y equal to the square root of x? So couldn't I call this point x comma square root of x? Because these two are the same thing, right? Good luck. Does that make sense what I'm doing here? To get to the square root of x there? And then I'm just going to plug in. So my distance would be the square root of, let's call this my second point and this my first point. It doesn't matter as long as you go the same direction every time. But in this way I did it, it would be x2 would be x, minus x1 is 5. y2 would be square root of x, minus y1 would be 0. And that would be your answer. That is the equation that we're trying to optimize. And it's down to one variable, so when we get to that point tomorrow, we can do that. Questions on that? For today, that's the answer. Today is just like set up the equation that we're going to take the derivative of make sure it only has one variable, and then stop. Talking what? Well, it's not that bad. So this is x squared minus 10x plus 25, and that's just x. You know, like square root of x minus 0 squared is just x, so it's not terrible. Alright, 3. I actually have a prop for this one. 14 by 30 sheet of cardboard. This is what I did during BRT. You're going to cut a corner, like a square out of each corner. So this is x by x, x by x, x by x. And then you're going to fold this box up. So it makes like an open box with no lid. Like so. Please like be impressed.
Wow.
So I want to make the volume as large as possible. So like, should I cut out big squares from each side and make it like tall and skinny? Should I cut out like really tiny squares and make it like long but thin? That's what we're trying to figure out. So we're trying to make the largest possible volume. What is the volume of a box? Volume of a box is length times width times height. Well, I need to write those all in the same variable. Let's look at how we do that. I've got a 14 by 30 sheet of cardboard. But then I cut out x from every corner. So this is like the drawing a picture part. So the shape that's remaining after I cut it out looks more like that. I don't know which is easier to look at. I want to know if you can tell me what that distance is. 14 minus 2x. Good. So all the way across the sheet of paper is 14. And I cut out x from this side, and I cut out x from this side. So some people would think about this like substitution. Some people would just put it in and not even think that you're doing substitution. But what I just determined is that the width of this is 14 minus 2x. So in place of width here, I'm going to put 14 minus 2x. Like, you don't need to write this equation, but it makes it feel more like substitution if you write it, because then you're just plugging in. But some people are just going to go, well, the width is, it was 14 when I subtracted 2x's, so I get that. The length, so the length is this distance. What's that? 30 minus 2x. Same reason. It was 30, I cut out x from that side, x from that side. And then the height is going to be what? The height is x, good, because that's like the part that's going to get like folded up. So this distance x will go up and become how tall it is. We're done. Like for today, we're done. I set up an equation that I want to maximize this. So if you wanted to throw like equals max on the side here, you could. But the way it was written, it's got 3 different variables in it. That's a problem. So I fixed that. And then tomorrow we'll take the derivative and figure out what to do from there. But questions I can answer on, I just set that one up. There's no questions because of my sweet visual aid, right? That's why I was further managing. Yeah, totally. Alright, let's look at 4. This is pretty tough. Try it. I don't know if you're going to do it or not. We'll see. I think it's tough, but we've only done like 3. Yeah. What do you drawing the picture is extremely helpful. That's my very loose sketch drawing. I didn't do too much yet, but that's what you're kind of working with. And you want to use as little wire as possible. The wire is like the diagonal. Still two?
I just drew buildings.
It's all just.
Well, you just add some boxes and then you got just add some boxes or whatever and make buildings.
Oh,
And you got the same thing.
I can't do that. Okay. This wire, this is wire, and this is wire. We're trying to make those as small as possible. I don't know how to help you notice this, but what I do notice is this is a right triangle and so is this. And so if I'm looking for this distance, what comes to my mind, like distance in a right triangle, is Pythagorean theorem. But we don't have it written down yet, like what we're supposed to use. But I know this whole deal all the way across is 30. So what I'm going to do is just pick, I'm either going to call this x or this x, it doesn't matter. Let's say this bit here is x. If I call that x, and the whole thing is 30, what's this part? 30 minus x. Like if that's 10, this has to be 20, right? If that's 5, this has to be 25. So this part here is 30 minus x. I don't need this anymore. And then, could you find this distance, or not find it really, but could you write out how to find that distance? It's Pythagorean theorem, right? Or you could use the distance. Pythagorean theorem is probably the easiest. But like 28 squared plus 30 minus x squared is going to equal this squared, right? 28 squared plus 30 minus x squared is going to equal, let's call that like W. Let's call it W1, like the first wire, equals W1 squared. Just Pythagorean theorem. Length squared plus length squared equals hypotenuse squared. So what would I do to that to get W1 by itself? This is the part where you tell me what to do to it. I would square root it, right? 'Cause it's squared. So W1 is the square root of all that stuff. 28 squared plus 30 minus x squared. So the big key that kind of unlocks the whole problem when you're stuck if you don't see it is this like x and then 30 minus x. Because that allows you to label both triangles. Then W2, if I call this one W2, well, that's just Pythagorean theorem as well. X squared plus 12 squared equals W2 squared. Right? Length squared plus length squared equals hypotenuse squared. And then W2 alone would be the square root of x squared plus 12 squared. Or if you want to make that 144, like whatever, it doesn't matter. Question on how I got W1 or W2. The two wire. And then what I want is like as little I want to add those up and give myself a number that is as small as possible, so I use as little wire as possible, so I spend as little money as possible. Question on how I'm getting any of that? Yeah. Wait, say it again. Not including the towers? Yeah, so I guess the tower's like here. So something like that. I should have drawn the tower. Does that make sense? Okay. Okay, so there's just, I think there's 12 or 13 to practice. I went through like 4 types. There are certainly going to be types I didn't go through. Can't go through every possible combination, and I don't want to do them for you because then you're not like me. But look at it, see if you can set them up. If you get stuck, ask. We'll figure out tomorrow like what were the hardest ones to set up. We'll go through a couple, and then we'll go through how to solve. But today you're just setting up. Fair enough? Why are you still looking at me? I feel like you expect me to say more than I have nothing else to say. Okay, go. It's working. All right, let's go. Let's rock. Remember the answers are on the website. Sometimes that's helpful, and then you can be like, oh, now I see it, now I understand. Please ask me if I can help explain whatever.